Welcome to our comprehensive Selenium Java Automation Testing Q&A series. I'm Career Assistant, and today we'll dive deep into the most commonly asked interview questions about Selenium WebDriver with Java. Whether you're preparing for your first automation testing role or looking to advance your career, this series will cover everything from basic concepts to advanced techniques. Let's get started. In today's session, we'll cover 7 key areas that are essential for any Selenium automation tester. We'll start with WebDriver fundamentals, then move through element locators, synchronization techniques, testing integration, and the page object model. I'll also share the most common interview questions I've encountered and provide you with best practices that will set you apart from other candidates. Each topic builds on the previous one, so make sure to follow along. Let's start with a fundamental question that's asked in almost every Selenium interview. What is WebDriver, and how does it differ from Selenium IDE? WebDriver is a programming interface that allows you to write automated tests in your preferred programming language, in our case, Java. Unlike Selenium IDE, which is a record and playback tool, WebDriver gives you full programmatic control over browser actions. WebDriver communicates directly with browsers through their respective drivers, ChromaDriver for Chrome, GeckoDriver for Firefox, and so on. This direct communication makes it much more reliable and flexible than IDE's plugin-based approach. Setting up Selenium WebDriver in a Java project involves a few key steps. First, you need to add the Selenium dependency to your project. I'm showing the Maven dependency here, but you can use Gradle as well. Next, you'll need the appropriate browser driver. In this example, I'm using ChromaDriver. A pro tip: instead of manually downloading and managing driver executables, use WebDriver Manager. It automatically downloads and manages the correct driver versions for you. Once set up, creating a WebDriver instance is straightforward, and you can immediately start automating browser actions. Element locators are the foundation of Selenium automation, and this is a question you'll definitely encounter. Selenium provides 8 types of locators, each with specific use cases. ID is the most preferred because it's unique and fast. Name is your second choice if ID isn't available. For styling-related selections, use class name .I. XPath is the most flexible, but can be slower and more brittle. CSS selectors offer a good balance of flexibility and performance. My recommendation: always start with ID or name if available, then move to CSS selectors and use XPath only when necessary. Remember, the best locator is one that's unique, stable, and performs well. XPath questions are extremely common in interviews, especially the difference between absolute and relative XPath. Absolute XPath starts from the root HTML element and follows the complete path. You can see how fragile this is. If any element in the hierarchy changes, your test breaks. Relative XPath, on the other hand, starts from anywhere in the document using double slashes. It's more flexible and maintainable. I always recommend using relative XPath with attributes like ID, class, or text content. You can also use XPath functions like contains, starts with, and acts as like following sibling for more complex selections. Synchronization is crucial in modern web applications, and wait strategies are frequently asked about in interviews. Selenium provides 3 types of waits. Implicit wait sets a global timeout for all element searches. It's simple but not very flexible. Explicit wait is condition-specific and more reliable. Use this for dynamic content. Fluent wait gives you the most control with customizable polling intervals and exception handling. My recommendation? No. Use explicit waits for dynamic elements and avoid mixing implicit and explicit waits in the same test. The key is to wait for the right condition, not just time. SDET integration is essential for professional Selenium automation, and it's a common interview topic. Testing provides powerful annotations that help structure your tests properly. Use @before method for driver initialization and @after method for cleanup. This ensures each test starts with a fresh browser state. The @test annotation marks your actual test methods, while @data provider enables data-driven testing. @val enables data-driven testing. Testing also supports parallel execution, detailed reporting, and test grouping. This combination makes your automation framework robust and maintainable. Page Object Model, or POM, is a design pattern that's absolutely essential for scalable automation frameworks. The idea is simple. Create a separate class for each web page that encapsulates all the elements and actions for that page. This gives you incredible benefits: code reusability, easier maintenance, and clear separation between test logic and page interaction. When a page changes, you only need to update one class, not multiple test files. Combined with Selenium's Page Factory for element initialization, POM becomes the backbone of professional automation frameworks. Dynamic elements are one of the biggest challenges in automation, and this question tests your practical experience. Dynamic elements change their attributes, positions, or content based on user interactions or data. The key is to identify what remains constant. Use explicit waits to wait for elements to appear or change state. Leverage XPath functions like contains or starts with for partial matches. Sometimes you'll need to execute JavaScript for complex interactions. The trick is to understand the application's behavior and choose the right strategy for each scenario. Best practices questions reveal your experience level and professional approach. Always use meaningful, stable locators. Avoid generated IDs or complex XPath. Implement proper wait strategies rather than hard-coded sleeps. Create reusable components and utilities to avoid duplication. Handle exceptions gracefully with try-catch blocks and meaningful error messages. Keep test data separate from test logic using external files or databases. Use version control for your automation code, just like any other software project. These practices make your framework maintainable, scalable, and team-friendly. Multiple window handling is an advanced topic that often comes up in senior-level interviews. The key concept is window handles, unique identifiers for each browser window or tab. Always store the main window handle first, then use get window handles to get all open windows. You can iterate through them to find the target window. Remember to switch back to the main window when done. This is commonly needed for handling pop-ups, new tabs, or multi-window workflows. A common mistake is forgetting to switch back to the original window, which can cause subsequent tests to fail. Before we wrap up, let me share some interview tips that will set you apart. First, practice coding live. Many interviews involve writing Selenium code in real time. Always explain your thought process as you code. Don't just give textbook answers. Discuss real challenges you've faced and how you solved them. Show that you understand framework design, not just individual commands. Demonstrate your debugging skills by walking through how you troubleshoot a failing test. Remember, technical skills are just part of the equation. Communication and problem solving are equally important. That's a wrap on our Selenium Java Q&A session. I've included links to essential resources in the description. Make sure to bookmark the official Selenium documentation and explore the practice projects on GitHub. If you found this helpful, please subscribe and hit the notification bell for more automation testing content. Drop your questions in the comments below, and I'll address them in future videos. Next week, we'll dive into advanced Selenium techniques including database integration, API testing, and CI/CD pipeline setup. Until then, keep practicing and happy testing.